Hi, Assalamualaikum. Our group from 5A will present on topic airport runway construction. This is our group member.
Hi, my name is Intan YASMIN binti TAZURI.
My name is MASTURA binti ABDUL.
My name is ALIAH binti KHAHARUDin.
The case study that we choose is Kuala Lumpur International Airport, KLIA. It is one of the world's busiest and most technologically sophisticated airports. The new KLIA is at Sepang Selangor, roughly 50 km south of Kuala Lumpur. Now I will explain about the definition of runway. A runway, the basic facility for an airport. It is built sturdy enough to withstand landing and takeoff of large passenger aircraft that weigh hundreds of tons. Meanwhile, for KLIA, it has 3 parallel runways. The runways can handle 120 movement per hour.
For planning, first one is pre-planning consideration such as coordination planning, procedure, planning organization, goals and policy objective. Second is forecasting for planning purposes. For example, methods and principle of forecasting, factors and presentation of forecast. Third is financial arrangement and controls like capital costs and operational costs. Fourth is site evaluation and selection. Fifth is runway and taxiways such as the dimension, strength, performance and runway length. Sixth is apron, layout of apron and apron accommodation. 7 is air and ground navigational and traffic control aids. 8 is passenger building. They need to consider the planning principle, airport traffic and service characteristic, capacity and demand. 9 is cargo facilities. 10 is ground transport and internal airport vehicle circulation and parking. And next is airport operation and support facilities such as administration, maintenance and medical center. Last one is security for airside security and landside security. As for Kuala Lumpur International Airport, KLIA, they also use this runway sustainability master plan. The master plan serves as a critical foundation for maintaining the safety of air operations at KLIA.
For the construction process, it consists of 5 steps. The first one is earthwork. It includes the excavation, trenching, hauling, backfilling and compaction. The second process is asphalt paving. Asphalt paving consists of supplying and applying bituminous material to a previously prepared and approved base course in accordance with the specification. The third process is runway pavement marking. A runway pavement marking will be using an emulsion paint. It consists of 3 main components that include runway number, runway marking and runway lighting. This is the runway clearing. The runway surface will be cleaned with rotating water jet. And the last process is runway test. They will test for the skid resistance using the Douglas MU meter. For smoothness using rolling straight edge. Concrete and asphalt are the 2 most typical materials used for runway at large airports. While concrete is generally more durable and lasts longer, it is also more expensive than asphalt. For the runway KLIA, it is made of flexible bitumen with a polymer modified with binder. This flexible bitumen used as it may contain a lot of energy transfer from the plane's tire to the runway surface.
Steel reinforced concrete and flexible bitumen with polymer modified binder are among the materials that normally used in runway construction. Both of these materials have its own unique characteristic in terms of effectiveness, maintenance record and lifespan. Based on our case study, the use of polymer modified binder has several advantages including improved overall structure and lower manufacturing costs. However, flexible bitumen with the polymer could no longer withstand the aircraft's engine blast and wakes. The wake of the plane as it taxis, lands and takeoff has an impact on the runway structural characteristics such as bending, cracking, depression and rattling. The term runway maintenance is usually used to refer to activity required to keep the runway in a safe condition for aircraft use. For KLIA itself, the scope of work will require overlaying works and some restatement of infrastructure including drainage and earthworks. The KLIA airport is provided with the Cut to Precision Landing (ILS) to safety guide landing aircraft in all weather situations. With visibility as low as 350 meters, it is 1,150 feet. The Airbus A380 can take off and land on KLIA's runways.
For sustainable consideration, airports considerably contribute to local economy and employment. However, together with the socio-economic benefits they offer, environmental costs and impacts are the inseparable result of the operations of airport. For KLIA itself, they are implementing these sustainable practices. First is improving energy efficiency by monitoring, analyzing and optimizing electricity usage to ensure the efficient use of energy. Second is reducing overall carbon footprint by controlling the number of vehicles at the airside, use of renewable energy and introduce low-emission vehicle. Third is enhancing waste and water management by rainwater harvesting using 3R system, which is reduce, reuse and recycle. The guidelines for runway orientation, it will depend on the direction of wind and sometimes on the extent area available for the airport development. Second is runway length calculation. Runway dimensions vary. For KLIA, there is 3 parallel runways. The length of runways is 4,056 meters long. Third is runway pavement. For KLIA, they are using a composite pavement structure.
And last is lighting.